Okay, so we've got Natalie Duffus with us here from the University of Oxford, and Natalie's going to talk to us about her work on biodiversity net gain in invertebrates and whether what that research is telling us about whether we're getting it right. So over to you, Natalie.
Thank you. Thank you so much, everyone, for giving up an hour of your time to listen to this talk. My name is Natalie Duffus. I'm a PhD student at the University of Oxford, and today I'm going to be talking a bit about what biodiversity net gain is and how it works, and then some of myself and my group's research into BNG and invertebrates. So to start off with, uh, Biodiversity Net Gain is a new requirement. So since February 2024, most developments under the Town and Country Planning Act have been subject to BNG requirements, with some exemptions. For example, developments that impact less than 25 square meters of habitat, householder applications and self-builds. And since April 2024, this has also come into force for small sites. So that's typically a development between 1 and 9 dwellings on a site of less than 1 hectare. And then from November 2025, this is expected to apply to nationally significant infrastructure projects, or NSIPs. So BNG is a wide-ranging requirement. It will affect housing estates and new renewable energy projects such as solar farms and underground cables. So a really wide-reaching requirement. And the kind of principles of BNG are that it aims to leave biodiversity in a measurably better state post-development. And to do this, it requires a minimum of a 10% biodiversity net gain to be achieved. That's the minimum, and some local authorities kind of have requirements for 20%. And the gains under biodiversity net gain must be maintained for at least a period of 30 years. And the approach, importantly, is achieved by enhancing and creating habitats. It's a habitat-based approach. And this is all measured using a tool called the statutory biodiversity metric, which I will go into in a bit more detail in a second. So what BNG looks like, BNG should be achieved by following the mitigation hierarchy. So that is this kind of order of preference of activities. So first of all, you should be avoiding impacts to nature, and then minimizing, then restoring, and then we get into the part where we're compensating for unavoidable losses through habitat enhancement and creation. And firstly, that can be done on-site, and then secondly, that can be done off-site. So just to get a picture of what that actually means, I've talked through the two different approaches because they're kind of important for some of the later points. So on-site BNG is where BNG is achieved within the development footprint, the red line boundary. So here on the left, we have an example of a proposed housing estate where in the beginning, they have a large area of arable site. And then post-development, they're proposing to have a housing estate on the north end of that, and then on the south end, a more kind of natural area. So achieving BNG entirely on-site. On-site can also refer to, for example, with solar farms, the area under and around the solar panels can be used to create habitat towards on-site BNG. And then also some more kind of green urban infrastructure, such as green roofs and green walls. So that's on-site BNG. Then we also have off-site BNG, which is where landowners, such as farmers, but also environmental NGOs, such as the Wildlife Trust and RSPB, and also some emerging new kind of business models, such as the Environment Bank or Biofarm. They enhance and create habitats on their land, and then the generated biodiversity uplift can be sold to developers who have a BNG unit requirement. So typically developers who've done as much as they can on site, but still have a remaining requirement, they can then purchase those units from those other landowners. And all off-site BNG transactions are recorded on Natural England's public gain site register. So there's a high level of transparency there. And then importantly, there's also a kind of backstop, a last resort, which is called the statutory credit scheme, which is where if you try to do as much on-site as possible and you can't find the off-site units that you need to fill the gap, you can then purchase a statutory credit from the Secretary of State to write off the rest of your BNG liability. And those are intended to be quite expensive to promote them as a last resort. And then then DEFRA should be spending that credit money on habitat enhancement and creation in England. So there are some kind of key differences between on-site and off-site, and I think amongst people who kind of work on BNG, there can sometimes be a bit of an on-site versus off-site debates, and I think there are a few key differences to keep in mind. So on-site BNG is seeking to keep the compensation as close as possible to the site of impact, so within where the original habitat was, and it delivers green space near to people, so it improves access to urban green space for the people living in these housing estates. But importantly, some work has shown that there's limited monitoring and enforcement capacity within local planning authorities, which means that some of these gains may eventually fall into what we've called a governance gap. So BNG is a 30-year requirement. There will be a lot of kind of urban habitats, such as amenity grasslands and trees and ponds, and there's a bit of concern about the kind of capacity within LPAs to monitor those throughout the 30-year time period. Off-site BNG, on the other hand, is typically seeking to deliver kind of larger landscape level projects. They tend to be larger habitat banks, more than 10, 20, 30 hectares, some even up to 100, 200 hectare projects. And there's a new legal mechanism which can be used to secure off-site BNG, which is called a conservation covenant, which is signed with a responsible body, which is an organization that's been designated as being able to enter these conservation covenants with off-site BNG providers. And the gains are recorded on a public register, and they therefore are more transparent than some of the on-site gains. So there's some important differences to think about, which we'll kind of come back to. But I want to talk about the statutory biodiversity metric now, because that's quite important when we're thinking specifically about invertebrates. So the statutory biodiversity metric is a simple area times condition proxy metric. And the way that it works is before your development starts, you look at all the habitats that you've got at baseline, and you look at their size and then their distinctiveness, which is a measure of the conservation value of a given habitat type, which is based on its rarity and its potential importance to species assemblages. And that gets assigned a numerical score, as does condition, which is a measure of the ecological condition of a habitat relative to its optimum state. And we'll go into a bit more detail on how those two are measured in a second. And then you plan your future scheme. You plan what habitats you will be retaining and what new ones you'll be creating, and you run the same calculation again. But because this is in the future and there's an element of uncertainty as to when these habitats will mature and if they will mature, there are also some further multipliers to account for difficulty, time to maturation, where the habitats are. So firstly, if the habitats are within the same local planning authority as the development, or if they're in an adjacent one or even further away. And then also a multiplier for strategic significance, which refers to whether the habitat is delivering on local nature recovery strategy objectives. So importantly, because this metric is multiplying area by distinctiveness and condition, there is a bit of flexibility in this metric. So there are trading rules which dictate which habitat trades are permitted. So like for like is required for high and very high distinctiveness habitats where possible. So very valuable habitats such as lowland meadow should be replaced with the same type of habitat. But for lower distinctiveness habitats, low and medium, there is a flexibility built in where a large area of a low distinctiveness or condition habitat can be traded up for a smaller area of a higher distinctiveness or condition habitat. So this flexibility allows for BNG to be achieved even when there's an overall decrease in non-urban habitat area. So these kind of three components, distinctiveness, condition, and strategic significance, Distinctiveness is based upon the level 4 habitat classification under the UK Habitat Classification Scheme, or UK HABS, whereas condition is an assessment derived from various tools. So for example, the Woodland Wildlife Toolkit, the common standards monitoring used for SSSIs, and some agri-environment tools. And from this, there have been created for each habitat a checklist of criteria based on habitat features. And this can be a habitat's condition can be assessed as poor, moderate, or good. And then, as I say, strategic significance is, does the proposed habitat match the local nature recovery strategy objectives? And I want to talk specifically for a second about condition under BNG and what that looks like. So here we have an example for medium, high, and very high distinctiveness grassland. So that includes other neutral grassland, lowland and upland acid grasslands, calcareous grasslands, and lowland meadow. And for those grasslands to be in good condition, the assessment states that they should have a consistently high proportion of UK HAB indicator species. They should have a varied sward height, at least 20% above 7 centimetres and 20% below, bare ground between 1 and 5%, cover of bracken less than 20% and scrub less than 5%, and cover of physical damage and species indicative of suboptimal condition less than 5%. And the species of suboptimal condition is something that I'd like to take a moment to focus on. So this is a list of species that is generated for each habitat type in the condition assessment process, which outlines species which are kind of designated as being indicators of bad quality in that habitat. And for grasslands, there's a list of them, which includes creeping thistle, spear thistle, nettles, cow parsley, creeping buttercup, white clover, greater plantain. There's a list of different species. And unfortunately, we know some of these species to be very important for invertebrates. So here's a really nice paper which characterizes the phenology of nectar resources on several farms and matches that with the demands of bumblebees to compare supply and demand in the nectar. And in this study, 50% of the nectar on the farms was provided by just 3 species, which were white clover, creeping thistle, and wild garlic. And 2 of those are what BNG considers to be species indicative of suboptimal condition. And this paper also highlights the complementarity of having semi-natural habitats such as grasslands and woodlands and hedgerows in a mosaic with pasture and arable field margins. And together, these habitats ensure a seasonal continuity of resources, preventing hunger gaps for bumblebees. And unfortunately, habitat mosaics are not necessarily well recognized within the metric. Having diversity of habitats and complexity is not something that's encouraged or valued in the metric, despite habitat mosaics being valuable for invertebrates beyond just the provision of nectar resources, but also ensuring that inverts with diverse habitat requirements across different life stages are able to kind of complete the full life cycle. So another kind of point on BNG implementation in invertebrates is that this is a study of early adopting BNG councils, so councils that adopted BNG prior to it going mandatory. And the authors of this study found that around 92% of BNG was delivered on site. And this is because large developments were able to achieve their entire BNG requirement on site very easily by using this flexible trading. So what we saw was that large areas of land were taken from cropland and low-scoring grassland, and then there were promises to deliver smaller areas of moderate condition other neutral grassland. So while there was a 23.5% increase in biodiversity units, there was a 38% reduction in non-urban green space. So this kind of poses another point to think about with invertebrates, is that many of the habitats created under BNG will be small habitats within the built environment, which is not going to be entirely suitable for all inverts. So to summarize, the potential limitations of BNG for invertebrates: the condition assessment may penalise features important for invertebrates. I use the example of grassland, but Many habitat types have similar features, which are penalising invertebrate important habitat features. There's limited recognition as well of the importance of connectivity and also site age, which we know are important for invertebrates. And smaller on-site habitats may have limited suitability for invertebrates. So this kind of brings me on to what we've been doing. So we have been, over the last few years, trying to answer this question of, does BNG metric scoring correlate with biodiversity, specifically invertebrates? And our research questions are looking at the relationship between the distinctiveness and condition scoring for grassland and arable sites under the metric and the abundance, richness, and community composition of ground invertebrates. So we chose ground invertebrates because they have relatively limited mobility and they have fast generation times. So we hope that they would respond on the same spatial scale as the metric. And we looked at grassland and arable because they are the most commonly kind of covered habitat types in BNG. And the previous slide, you saw kind of a lot of low distinctiveness grassland and arable being converted to medium distinctiveness grassland. So to answer this question, we did pitfall trapping on arable and grassland sites for ground invertebrates, which is beetles, spiders, millipedes, centipedes, woodlice. And then we did the UK habitat classification and the metric assessment on those same sites. And then we sorted and counted the ground invertebrate groups in each site to get the abundance. And then we did this over 2 years with slightly different approaches. In the first year, we identified just carabid beetles to species. It's a group of ground beetles, and we did that manually. And in year 2, we used DNA metabarcoding for species identification. So this is where the DNA is extracted from the invertebrate samples, and the DNA is used to generate a species identification. And that allowed us to characterize a much more kind of complete set of invertebrate groups than just the carabids. So onto the results of this work. Here we have the distinctiveness and condition score along the x-axis, and then the mean ground invertebrate abundance up the y-axis. And we found that there was no consistent correlation between abundance and scoring, and this was for total groups, but also when you look at individual groups, such as spiders or beetles. And as we would expect, abundance does vary in time quite substantially, and by groups for each of our sites. For example, spider abundance peaked and dominated the samples in May, particularly in lowland meadow, but then dropped down again in June and August. And some habitat types were also particularly variable. For example, other neutral grassland, which is a very commonly created habitat under the metric, was very variable. And then we looked beyond abundance to look at species richness, so the number of species in each habitat. And as I said, in year 1, just for the carabid beetles, and in year 2, the total community. And again, we found that there was no consistent relationship between the two variables whatsoever. And interestingly, in our first year for carabid beetle richness, some of our highest scoring sites were our arable field margins. And these are sites which score pretty poorly in terms of their distinctiveness and condition. And we had species such as the bombardier beetle, Brachinus crepitans, in these field margins. And that's a species that is nationally scarce in England, and that's the only site that we identified that species. And kind of speaking of species that kind of have a conservation designation or are declining, that's obviously also a very important metric to think about here, because maybe some of these more distinct habitats might have rare or unique invertebrate assemblages. But when we looked at specifically community composition and the occurrence of species of conservation concern, we found this not to be the case. So here we have these clustering plots by habitat type. And basically what we would expect is for each habitat type to have a kind of cluster to show that the communities are distinct from each other. But what we have here is very overlapping communities. So it shows that the communities in each habitat are not dissimilar from each other. And we found that species of conservation concern, such as UK BAP or the NERC priority list species, were found across most of the habitat types in our sample uniformly. There was no kind of concentration of species of conservation concern in the higher scoring habitats. For example, the necklace ground beetle, Carabus manilis, which is one of England's fastest declining ground beetles, was found on MG4 floodplain meadows in our samples, but we also found it on poorer scoring grasslands, such as modified and other neutral grassland in kind of much more arable contexts. So what does this kind of all mean, all this kind of data on ground invertebrates? What we kind of summarize our overall finding is that the metric score in isolation is not predictive of ground invertebrate abundance or richness. We find that the variation in invert abundance and richness just cannot be explained by measuring habitat distinctiveness and condition in the way that the metric currently does. So what does that mean for the actual policy's ambition to deliver BNG? Well, firstly, BNG may undervalue sites which are important for insect biodiversity. So a low metric score could actually be masking a high invertebrate richness or abundance. So you might assume that arable field margins or low scoring grasslands have poor biodiversity, when in actual fact that might not be the case. And secondly, when creating new habitats, which are intended to compensate for damages elsewhere, the use of the metric may not lead you to design sites which support high levels of insect biodiversity. We spoke about that condition assessment criteria. If you're using that to design a good condition grassland, you might not create something which is good for invertebrate biodiversity. And I just want to share a couple of other studies which have looked at other taxa. So the first one is looking at butterfly and bird abundance and richness, and also plants. And they found that there was no relationship between the metric score and the abundance and richness of butterflies or birds, but they did find a relationship between the metric score and plant diversity, which is very interesting. So the higher the metric score, they found that there was higher plant diversity, which I would perhaps suggest could be slightly endogenous to the metric, because as part of the metric's scoring system, you measure plant diversity. So it's incorporated into the score. But for butterflies and birds, no relationship. And then another interesting piece of work was sampling planning applications before BNG was mandatory. And it was looking at the metric score, and it was looking at species of conservation concerns found in those same sites, so where the planning application was put forward, and again found no relationship between the metric score and the occurrence of species of conservation concern. So it's quite clear that as currently designed, the metric is not reflecting kind of species diversity or abundance. So we've kind of been thinking about how we can design BNG so that it does deliver a net gain for inverts. And to kind of do that, we need to think about the way that the metric currently works, taking a very simple view of habitat quality, for example, not recognizing the value of connectivity, habitat heterogeneity, or complexity. But we think with some policy changes, we could start moving towards a system that does value and incentivize larger, complex, heterogeneous habitats, which are well connected. So this could include by updating the condition assessment criteria so that they encapsulate habitat complexity and heterogeneity, and also take out some of those criteria that we know are not working for invertebrates. Or also by building in a connectivity multiplier into the metric. So there used to be connectivity in a previous version of the metric 2.0, but it didn't work very well as far as I'm led to believe, and so it was ultimately removed. But I think connectivity is very important. So I think kind of revisiting that idea would be helpful. But kind of more broadly, I think this serves as an important reminder on why collecting species data is important in the planning and development process. So we can only mitigate and compensate for impacts upon species if we know that they're present. And species data can be integrated into decision making. So if you know that a particular area is important for a given species, you can design the habitat creation appropriately. So although my kind of slightly balanced and nuanced conclusion is that although BNG is not perfect, I do believe that it can be improved. And I think it's important that we strive to improve BNG rather than calling for a reversion to a pre-BNG world, especially in light of other planning reforms. So by other planning reforms, I'm talking, of course, about the new Planning and Infrastructure Bill, which is a proposal to implement a nature restoration fund. And the way that this works is environmental delivery plans will be created, which outline environmental harms, which will be covered by the fund, and the levies to be paid by the developer. And this is likely to cover mitigation for various protected species and habitats. So for example, an environmental delivery plan could be created that says, if you are a development in this area, you're likely to impact bats, so you need to pay this amount of money to compensate for that. And this bill entirely disconnects the kind of level of impact from the level of compensation in a way that the BNG definitely still does. BNG is good for promoting adherence to the mitigation hierarchy for habitats. This kind of new nature restoration fund entirely divorces impact from compensation, making it impossible to adhere to the mitigation hierarchy. Importantly, it has been stated that BNG will remain unchanged by the Planning and Infrastructure Bill, although there are insufficient legal safeguards to actually ensure this. In theory, the Planning and Infrastructure Bill can supersede any environmental legislation that that Natural England kind of decides to write an environmental delivery plan for. So there's kind of two references there to kind of read more on that, because I think it's a very important kind of conversation, and I think the impacts of this bill are massive. So I'd be keen to share those. So to kind of wrap up what all this means, I think that BNG is an ambitious idea for embedding habitat mitigation into the planning process. I think, but the benefits beyond habitat enhancement and creation cannot be assumed. You cannot assume that because you are dealing with habitat through BNG, that species will also be benefiting from that approach. And I think changes to the metric could better align BNG with invertebrate conservation, but I think there are limits to a proxy biodiversity metric based on habitat. It's never going to perfectly align with the kind of variety of species assemblages unless you're actually measuring them. So I think bearing those limits in mind is important, and remembering that collecting species data remains essential for kind of truly measuring biodiversity impact. So thank you for listening to this talk. I'd like to thank Tom Atkins at Newcastle University for co-authoring all of that beetle collecting and counting, and Owen Lewis, Richard Grenier, and Sophus Sorangasan for their supervision, and obviously the funders and landowners too. Thank you very much. Happy to take any questions.